Hey guys, John from Gaddy's Garage. Today we're going to machine a hub and fit all our pieces in our custom one-off wheel build. Stick around to see how. Hey everybody, welcome back. Saturday in the shop as usual, and gonna jump back on our wheel build for our 24-hour bike project we got coming up. Plan for today is to get all the parts machined for the rear hub. We've got to make the sprocket mounting flange, drill out the material, bore for the bearings, make a bearing spacer, and hopefully that will all get done today. We have, I'm just looking at the wheel up here, so we have to machine the center still. That probably won't happen today. Wanted to get a couple of these things machined out so that we're getting closer to being ready to weld this thing together. I did order a new weld positioner, a little rotary type table weld positioner, so that's just going to allow me to do a nicer job welding this stuff. The part will spin for me, so I'll be able to do one continuous weld all around, like where the flange is going to mount to the hub, where the hub is going to mount to the center of the wheel. Anyway, that's where we're at. Got lots of metal to cut away, and we're going to jump out on the lathe and get rolling.
Alright, so first things first, got a piece of 2-inch solid we're going to use as the basis for our hub. You may be thinking, why are we using solid and not tubing? Well, I had the solid and a short 1-foot piece of tubing, 2-inch diameter with a thick wall was about $65, and I said, not a chance, we'll just use what we have. So we got it in the lathe. We're going to go ahead and bore it out. Got an 1.25 inch twist drill. A little bit of a pain at this length. It's just at 7 inches long. The twist drills are only about 4 inches long, so got a little back and forth having to pull the bit out to clear the swarf. The cutouts in the twist drill kind of get impacted and just don't clear the chips after they get too deep in the part. So a little bit of a pain, but nothing we couldn't handle and get through. So we got our piece of solid essentially turned into a piece of tubing. Then we went ahead and dropped our boring bar on. We're going to bore each end. We need to bore a recess for our bearings to fit in. Got a 2-inch OD, and these bearings are 1-inch 750 outside diameter. So we'll go ahead and get each end bored. Little bit of a press fit. The one side I actually make size on size. The bearing just drops in there because we're going to be pressing a flange onto that. And I found that once you press the fit into the new flange, it's going to squeeze that down a little bit. So I made it a tad on the loose side. You can see right here the bearing just barely slides in once I pick it up from dropping it. And we can get it, it'll drop it again. Because, I don't know, clumsy this morning. I don't even remember dropping that. But anyway, it slipped in there. So now we're just go ahead and cleaning off all the mill scale on the piece of tubing. So we got a nice clean piece. Going to put a regular outside cutter on and turn a little nose on here. The dimensions are not really that important. We're just turning a nice concentric area. Cut about 25 thousandths off, so that we have somewhere for our brake rotor, or not brake rotor, our sprocket flange to press on. So again, just a simple single cut on that, and it allows us to have a nice machine surface as opposed to just the outside dimension of the tube. It also gives us a stop to press the flange against, as opposed to us leaving the tube the full size and the flange could essentially slide all the way down. So we got our sprocket flange in the lathe now. Went ahead and center drilled that. Again, just using a large twist drill, going to open up a center hole to allow for our boring bar to go in there. Going to bore this out to our hub dimension, which I believe was like 1 inch 930 or something like that. Again, that dimension doesn't really matter. It was just to have a nice clean surface on the outside of our hub. So, see there, we use our snap gauge to check our dimension. Always like to sneak up on these press fits. It's real easy to go a little over and turn your nice part into a piece of scrap. And with material costs these days, that is absolutely no fun. This little piece of material you're looking at here, 4.5 inch diameter, 1/2 inch thick, was like $35. So you hate scrapping this stuff anymore. Anyway, you see us, bore check. Just standard operating procedure when you're making these kinds of parts. We get it down to our dimension we like. We head inside to our press, get everything lined up, put a little piece of scrap on top, and press our round tube and our sprocket flange together. With our two pieces now basically one, we went back to the lathe. We're going to take a quick pass just to face off and get a nice clean perpendicular surface for our sprocket to ride on. Also, we're going to take just a skim cut off the outside diameter of the 4.5 inch piece of material. Again, this is just to clean everything up, get rid of our mill scale, and have a nice concentric part so that everything's nice and clean for our final product. Once we get that done, we're going to move on to cutting the shoulder for our sprocket to line up on. The sprocket hole obviously is smaller diameter, and then you have the bolt pattern around. So the idea being that that shoulder centers your sprocket, and then your studs bolt the sprocket on. So making a quick change on the carbide tooling. The old tip looked a little funky, so since we're going to be making our finished cut here, went ahead and swapped that around. We're going to make our first little cleanup pass, and then we'll lay out some Dykem layout fluid on there and mark our depth. I believe it was about just over 1/4 inch, which is the sprocket thickness, maybe 280 thousandths or something in that range. So we're basically cutting down from 4.5 inch to just over 2.5 inches. It's a real time consuming process. I actually considered making this hub all one piece, but that was going to require starting with a 4.5 inch diameter piece of steel, machining it down, to the hub dimension everywhere except the flange. And I just thought the time that was going to take was going to not really be a payoff. So you can see here we got our shoulder just about where we want it. Oh no, that is after the finish pass. Okay, so got our sprocket fit on there. Nice slip fit. That you don't have to have a press. Obviously, you want to be able to get your sprocket on and off relatively easily. And that will get a bolt pattern drilled in it. We'll install some studs, and it'll be held on with some flange nuts. Nice close-up, if this camera will focus. There's our hub with our bearing bore. That flange will ultimately be welded onto the hub inside and out. Just have not gotten to that part of the build yet. So we got finished a lot quicker with the hub than I thought we would. So went ahead and installed our wheel center, which we cut in a previous video, onto our mill to bore the center hole. I used a plasma table to cut this, and because the plasma table accuracy, especially on inside holes, is not the greatest, I just cut a 1/2 inch hole in the center. I'm going to put a 1/2 inch end mill in the milling machine and use that to align to that center hole here in a minute. That way we just move the table around till we get the end mill to drop in and we've got our center. Then I'll swap that out for 1 3/4 carbide hole saw and rough cut our hole to 1 3/4. After getting that hole roughed out with the hole saw, we install the boring head. And again, we want this to be a light press fit. So we're just going to sneak our way up on it, boring, use our snap gauge to take a measurement, boring, snap gauge, back and forth, back and forth. Again, I do not want to scrap this piece of material. It's already been cut. It's expensive, blah, blah, blah. So anyway, that's what we're doing. Just bore, make a pass. And I think it took us, I don't know, maybe about 8 or 10 passes with the boring head to get opened up to our dimension, which was, I believe, just under 2 inch, like maybe 199, could have been 201 even. And you can almost force the hub in. It'll take a super light press, which is basically exactly what we were shooting for. So again, you just see us boring, checking. Just a slow, tedious process. What you see here today in this video, which I think we got down to around 30 minutes, is essentially 5.5 hours of work. So here we got the hub. I'm going to drop the table down. We don't want to move the table or move the boring head, so we just got to drop it down straight up and down. Won't lose our zero. And then we're going to just check fit. Although, yes, you can measure. I always like to check with the actual part if you have it on hand. It's, the actual part's never going to lie. You can mismeasure. You can read the caliper wrong, but using the actual part will always tell you what you've got. So here we've got our wheel center, and you can see our hub, which just barely doesn't fit in there. Almost, but not quite. And this is where our day sort of went haywire. We've got our rotary table on. If you watched our previous video, you remember we cut our centers slightly oversized from the inside diameter of our wheel hoop, so that we could machine it to size. Again, just dealing with the fact that the plasma table is not the absolute most accurate machine. Plus you deal with kerf and some other stuff like that with the plasma. So anyway, my thought was to clamp this in the rotary table and come in and just machine the outside diameter of our center to the dimension we needed. So started out, put an end mill in, and the chatter, the end mill, it just did not like cutting this interrupted cut. It sucked. I tried to make a couple passes, cutting like literally 1 or 2,000th passes at a time, and it just would not cooperate. Okay, so after the end mill debacle, I scratched my head and decided to try and put a grinding stone in here. We sped the mill up to, I don't know, max speed, whatever that is on it, 4,000 or 5,000 RPM. And while it didn't chatter, the stones, I don't know if it's just a bad quality stone I have or if the material's that hard. It's really not that hard of a material. It's just regular old steel. Anyway, it was just chewing the stone up. So I'd get 4 or 5 nice cuts on the individual little tangs, and then the stone diameter would be ground down so small that we weren't getting any positive material removal after that point, which makes for an extremely difficult to make a concentric cut when your cutting material keeps disappearing as you're cutting. So that also sucked equally as bad as the end mill, and at this point I was starting to dream of grinding this by hand, which I just knew was not the answer, and I knew there was no way that that would be accurate or work well. So took a break, scratched my head, and could not come up with anything for quite a little bit of time. So, as a last option, Matt came over to see what I was doing. He could see I was struggling, and he said to me, how about a carbide burr? And that made a lot of sense. Carbide burrs are a little bit finer cut. I had a nice double cut carbide burr, square sides. And so I said, hey, let's try it. Nothing else seems to be working. And that was the answer. The carbide burr was smooth enough. It wasn't grabby like the end mill. I was able to run it at a higher RPM, and it was just a great tool to use to do this job. The lack of rigidity did not cause any problems, and it allowed us to cut nice concentric part. Again, lots of passes. I was taking 4 or 5 thousandths at a time, but it's a tedious process, and it's not something you want to get carried away with anyway and end up cutting your part too small. So doing that was fine with me. I had planned on cutting it a few thousandths at a time anyway, using the end mill. And again, same old process, using the rim hoop. We make a cut and we check, and we make a cut and we check. And when I started to get close, I popped out the big boy calipers we got a couple of weeks ago and started making measurements. And then I had an idea, I need to take 12 more thousandths off, and we snuck up on it 5 at a time. And anyway, we ended up getting this cut down perfect, nice slip fit. It is about just under a tenth or just under a thousandth, maybe 8/10 undersized. So it's a slip fit with just a touch of a gap, which is fine with me. We're going to clamp it all together onto a table when we do our welding. And I was worrying about the possibility of some pulling. So by having that little bit of a gap, I think it'll allow us to work around any pulling that occurs as we weld, side to side, back and forth, to keep the rim and all straight during the welding process. Again, this is nothing I have ever done. I could be completely wrong, and I could be spending all this time machining all these parts and making scrap. I hope not, but that's kind of the nature of doing things for the first time. If for whatever reason this doesn't work, at least we will have learned something. But I'm pretty confident in what we're doing, and I think we've got the process pretty well figured out. So here we're just making our final pass. Had to take another 1/1000 off. Just a real small cut, a little bit removed. And we're going to come back in here with our rim hoop. And zoom it in so you can see. And nailed it. Nice slip fit with almost no lateral movement. Exactly what we wanted. Couldn't be happier. This wheel looks so cool. I can't wait to make the front 21. And I just don't know what to say. That's it.
All right, guys, that's a wrap for today. We got a lot more done, actually, than I even thought we would. We got our hub completely machined, recessed for our sprocket. We still have to drill and tap this for our sprocket mounting studs. But other than that, this is done, except for being welded. I didn't weld it because I did order a welding positioner that is coming hopefully this week. That'll let us get a much better weld than we would freehand. We got our center bored out, and machine down. You saw on the mill that took a little figuring, you know, everything doesn't always go exactly as you planned. I thought we'd be able to cut it with the end mill. We couldn't. We tried using a grinding stone, but the stone quality these days is just pretty minimal. Matt's here and he said, how about a carbide burr? Thought, hey, let's give that a try, and perfect idea, worked great. Got this thing, it's a slip fit by about just under 1/1000th. So we'll get our dimensions measured. We'll make some standoffs so we can sit this flat on the table, tack it into the rim hoop nice and square. And last thing we got to figure out, which will come next week or whenever, is we got our perimeter brake rotor, which we're going to mount here. Just got to figure out kind of how I'm going to do that. Obviously it needs some standoffs. It will stick out of the wheel for enough room for the caliper. And I'm still debating if we're going to put that on the sprocket side, or opposite the sprocket. Originally I thought the sprocket side, but now I'm thinking it'll be a little too cluttered, plus the chain will kind of partially cover up the perimeter rotor, and it's such a cool look, so I think we're gonna probably do that on the opposite side. But plan is to get the wheel all assembled, and then we'll figure that out as kind of the last piece of the puzzle. So that's it. We're gonna get out of here. Appreciate you guys being here as always. Hope you enjoyed watching some machine work and watching us figure out kind of all the little trials and tribulations that come up with doing something for the first time. So that's it, and we hope to see you next time at Gaddy's Garage.